So in this travel or distance problem, we have Jackson, who is riding a unicycle. His average speed is 11.5 miles per hour, and he's taking a round trip of 40 miles. We do know that it takes him 1 hour and 20 minutes with the wind and 2 hours and 30 minutes against the wind. So there's a lot going on in this problem. We're still going to set it up just like we did with our example problem from the beginning of the week. It's just with this one, the numbers aren't going to be as nice as we work through the problem. So the first thing we do need to realize is that we're going to use distance equals rate times time. Now we're going to manipulate this problem by dividing both sides by our rate. So we end up getting our distance over our rate equals time. So let's talk about our time first. If it takes him 1 hour and 20 minutes to go out and then 2 hours and 30 minutes to come back in, that's a total of 3 hours and 50 minutes. Now since we have 2 units of time working here, hours and minutes, we want to convert them so we only have 1 unit of time. Now if I look back into our problem, we're using hours in our rate. So I'm going to convert 3 hours and 50 minutes into just hours. So to do that, we have 3 hours and 50 over 60, which is just 5 over 6. Now using a mixed number doesn't really help us in algebraic problem solving, so we're going to put this as an improper fraction. So 3 and 5, 6 is actually just 23 over 6. So the total trip is 23 over 6 hours. Now we're going to talk about the distance. So since it's a round trip of 40 miles, we know the distance that Jackson traveled out and the distance that he traveled back in are both 20. So we know our distances are going to be 20 going out, 20 going in, and as we build our equation, it's going to equal our time, which is 26 over 6. Now the last part is our rate. Now with our rate is always going to be your rate, so without any wind, without any current, plus or minus nature. So whatever nature's rate, so whether it's wind or current speed. So we were told that his speed is 11.5. So it's going to be his speed of 11.5 plus or minus nature's, or the wind speed in this case, which we don't know, so I'm going to call it W. So we would put that into our denominators as 11.5 plus W, 11.5 minus W. Let me box up this equation because we've got a lot going on. So if we go back to our original equation, which I'll highlight here, this equation right here, our time again was 26 over 6 hours. Now we have 2 distances working at once. We have this distance here, which we can consider Jackson's time going out, plus the distance over rate of him coming back in. So the distance in either case, again, is 20 miles per hour, and then the rate, depending whether he's going with or against the wind, will be his 11.5 plus the wind speed or 11.5 minus the wind speed. So to solve this equation, we're going to get a common denominator, and our denominator is going to be 6 times 11.5 plus W times 11.5 minus W. So I'm going to multiply my first fraction by a 6 over 6, and the 11.5 minus W over 11.5 minus w. Second fraction, we're going to multiply by a 6 over 6, and we have the 11.5 plus w over 11.5 plus w. And then our final fraction is going to be 11.5 plus w over 11.5 plus w, and then 11.5 minus w over 11.5 minus w. So now you can see we all have common denominators, and we can multiply that denominator through, and that would cancel everything out. So essentially what ends up happening is if I multiply both sides by 6 times 11.5 plus w, 11.5 minus w, all the denominators end up simplifying and canceling out. So I would just be left with what's in the numerator. So I'm going to write what I have in the numerator, but I'm going to simplify it just a little bit because I know that 6 times 20 is 120. 11.5 minus w. We have the plus. Again, 6 times 20 is 120. 11.5 plus w. We still have equaling 23. And I'm actually going to FOIL this out. And if you guys can remember back when we were factoring, this is a result rather of a difference of 2 squares. So if I FOIL that out, I'm really only needing to multiply the first two, which is 11.5 times 11.5, and my last two, w times w. The two middle terms would end up canceling out. So if I multiply the 11.5 times the 11.5, I get 132.25, and then I have minus w squared. So now I'm going to continue to simplify this out. I see that I'm going to have 120 times 11.5 and 120 times negative w. I also see I have another 120 times 11.5, and in this case the 120 times positive w. So the 120 w's will end up simplifying out, so I'll just have the 120 times 11.5 times the 120, or rather plus the 120 times 11.5, which is going to end up being 2,760. If you need to multiply that out just to wrap your head around that, go right ahead and do so. On the right side of the equation, when I distribute the 23, you end up getting 3,041.75 minus 23r squared. So this is a quadratic equation now. So typically what we'd want to do is set it equal to 0, try and factor, or use the quadratic formula. I noticed that I don't have an r term, so no b term, so I can actually solve this by taking square roots. So what I'm going to do is I'm going to subtract the 3,041.75 on both sides. I end up getting negative 23r squared. And on the left side, I'm going to get negative 281 point, I believe it's 25. I'm going to divide now both sides by negative 23. And if you do that in your calculator, you might end up getting something a little crazy. So I'm going to leave it as a fraction right now. So what I have right now is r squared is going to be positive 281.25 over 23. Now to get r by itself, I'm going to take the square root of both sides. And remember, when we take the square root, typically we end up getting solutions that are going to be plus or minus. So we would end up getting r equals plus or minus, and this actually works its way out to be 3.5 miles per hour. Now typically we don't have negative wind speed. Really, in this problem, that just means you're going against the wind. It's giving you sort of direction, which those of you that take physics, kind of almost like a vector. But our solution is going to be 3.5 miles per hour.